Hello, my name is Ryan, and today I'll be showing you two different methods for finding the formal charge in Lewis electron dot structures. First, starting with what even are Lewis structures? Molecules surround us, but have you ever actually seen what a molecule looks like? Probably not. Lewis structures help us visualize the bonds in a molecule, which can tell us its shape and its properties. They show valence electrons, which are the only electrons available for bonding. There are other electrons within an atom, but these don't matter as much for deciding the structure. Lines represent shared electrons or covalent bonds, and dots represent the non-bonding electrons that are just floating around having a good time, sometimes called lone pairs. You can either have a single, double, or triple bond, which are represented by a single, double, or triple line. So you can see in this acetone diagram, there is a double bond between the central carbon and oxygen atoms, while the rest of them only share a single bond. So why do we even care about formal charge? Why is it important? Well, what you may find when drawing Lewis structures is that there are several often correct ways to draw them. You can see in this diagram of the cyanide ion, there are 9 different ways to draw it, all technically correct. So, how do we actually know which of these possible structures the molecule will take up in real life? Formal charge helps us predict just that. The most ideal structure will have minimized formal charge, and the negative formal charge will be positioned on the most electronegative atoms. So let's take a look and see why F is the correct structure here. The little red numbers represent the formal charge of each atom, and the black number represents the total overall charge of the ion itself. So, and this should equal the ion's actual charge, and that can help you check whether you've drawn your Lewis structure correctly. So for the cyanide ion, its charge is -1. So all of these structures, their overall charge should be -1. If we were doing, let's say, phosphate, the overall charge would be -3. So when you add up your formal charges, they should all end up equaling -3. So out of all of these resonant structures, E and F have the most minimized formal charges. You can see that they have 2 zeros, while the other ones may only have 1 zero or no zero. So those are the two final possibilities. So why is F correct? It's because oxygen is more electronegative than nitrogen, so the remaining -1 formal charge should be placed on the oxygen, while E places it on the nitrogen. So the most often taught method is the mathematical formula, where the formal charge of an atom equals the atom's valence electrons minus the sum of its non-bonding and bonding electrons. So the reason that there is a half built into this equation is because each line or bond actually represents 2 electrons. So let's find the formal charges for C, for this ozone molecule. So oxygen has 6 valence electrons, and this one has 4 dots, 4 electrons, so that's 4 non-bonding electrons, and it has 4 bonding electrons, which are contained within the 2 bonds. So that's why you have the half there. So its overall formal charge is 0. The central oxygen still has 6 valence electrons. It has 2 non-bonding electrons, the 2 dots, and it has 6 bonding electrons with the 3 bonds. So its overall formal charge is +1. The rightmost oxygen still has 6 valence electrons. It has 6 non-bonding electrons with the 6 dots, 3 lone pairs, and it has only 2 bonding electrons because of the single bond. So its overall formal charge is -1. So when we add these all together, its overall charge is 0, which makes sense because the overall charge for the ozone ion should be 0. The second method is called the attachment method, and it can be better for visual learners. So first, let's define what attachments are. Well, they're simply lines or dots. So every time you see a line or a dot, that counts as one attachment. It's pretty simple. So to determine the formal charge, all you do is subtract the number of attachments you see from the atom's number of valence electrons. So let's do it for the same ozone molecule. It still has 6 valence electrons, but we have 4 dots and 2 lines. That's 6 total attachments, so its overall formal charge is 0. For this central oxygen, still has 6 valence electrons, but it has 2 dots, 3 lines. So it has 5 attachments, which means its overall formal charge is +1. The rightmost oxygen still has 6 valence electrons, but it has 7 attachments because of its 6 dots, 1 line, which means its overall formal charge is -1. Add them all up just to check, make sure it's 0, and we got to the same answer, but we didn't have to do hardly any math. So why the attachment method, since both accomplish the same thing? Let's compare the two methods and see why it might be a better option. So the math method requires a formula, while the attachment method relies on visual accounting. You don't need any formula. There are fractions in the math method, but the visual method has no fractions, less arithmetic. In the math method, you need to know the difference between bonding and non-bonding electrons, but in the attachment method, we don't care. It's just you see a dot, you see a line, that's an attachment. It's directly related to visualizing the Lewis structure. Finally, the math method has that separate calculation step where you can make a mistake, but the attachment method, you're just looking at the page and seeing what's there. So it's best for visual learners, and you don't have to do any math. And we know that most learners are visual learners, and since you aren't having to do any math, you can perform this method much faster. So the attachment method's success was measured by a 2024 study that involved 426 Chem 1 students at UC Davis. They were given a test which asked them to find the formal charge of various Lewis structures, and at the end they were asked which method they preferred. The pie chart shows that 77% of the students selected either attachment or both, showing a clear preference for that method. When researchers compared test scores, students that selected the attachment method on average got 1 more question right over those that preferred the math method, and 2 to 3 more questions right over students that preferred neither method. So next time you are tasked with finding formal charge, consider using the attachment method. Thank you.